All right, in this lesson we're going to take a look at slope, distance, and midpoint. Now I know you've done slope before, but maybe distance and midpoint's new, a little bit new. We're going to learn three formulas: the slope formula, distance formula, and the midpoint formula. They're going to have uses throughout this module. All right, we're getting into a new module now. Coordinates. We're going to look at different shapes and lines and circles all on the coordinate plane on the x and y axis. Okay, you're not going to see any graphs in this lesson because you don't really need it, but it's all kind of applying to that. So let's say we have a line passing through the points 2, -3, and -5, -1. We want to find the slope. So to find the slope, we need the slope formula, which again, this should be review. Slope is y2, that's not a y, y2 minus y1 over x2 minus x1. So that's going to be -1 minus -3 over -5 minus 2. So it's going to be 2 over -7, which is -2 over 7. So the rise over run, the slope is -2 over 7. All right, that's a review of the slope formula. If you ever need that, you're going to need that, but we're going to show you in other lessons where you're going to use it. Really, I want to focus on distance and midpoint here, though. Distance formula is used when you want to find the length of a line segment, okay, or the distance between 2 points on a coordinate graph. Okay, so let's say I have a graph x, y, and one point is here and one point's here. I can't count because it's diagonal. I can't count. If it was like just left and right, if it was horizontal or vertical, I could just count up, right? Or count over. But because it's diagonal, I can't do that, so I have this formula that will do it for us. You could also use the Pythagorean theorem, which we'll get into later on. But anyways, a couple different uses here of this. In part A, they say, is triangle ABC an isosceles triangle? So they have point A, point B, and point C. All right, so I have one point. I'm just going to actually graph these just to get an idea of what we're talking about here. So one point is 0, 3. So that's like right there, let's say. And then B is 3, 7. 3, 7, somewhere up there. And then C is -4, 6. -4, 6. So right there, right? And you have to connect the dots, and then you would determine, is it isosceles? Well, to determine if it's isosceles, you would need two sides the same length. Well, how do we find length? We use the distance formula. So basically, the distance between all the vertices, we're going to do all of them. So we're going to need the distance formula 3 times. We're going to do AB. Let me move that up. So we need AB. We need BC. And then we need AC. So for AB, distance formula, it's right here. Subtract the x's. So A and B, right? A and B, 3 minus 0. 3 minus 0 squared. And then you subtract the y's. Subtract the y values. 3 and 7. So 7 minus 3 squared. All right? So that's going to be, I'm just going to move it down here. 3 minus 0 obviously is 3, so it's 3 squared plus, and this is going to be 4 squared, which is the square root of 9 plus 16, which is 25, which is 5. So AB, where was AB? 0, 3 to 3, 7, right here. This is a length of 5. That's a length of 5. Okay? BC. So we're doing these two now. Radical. -4 minus 3 squared plus 6 minus 7 squared. Square root of, this is going to be -7 squared plus -1 squared. So that's going to be 49 plus 1, which is 50. So we'll call it square root of 50. You could actually put that in your calculator, but it's square root of 50. That's BC, so that's going to be B37 to this one. So this is radical 50 here. All right, it's off your screen a little bit. I know that. Let me move it down a little bit. There we go. Radical, move right back. All right, so 5 here, radical 50 here. So this piece here, this AC, that's either got to be 5 or radical 50. If it is, it's going to be isosceles. If not, it won't be. So AC is going to use A and C. It's going to use this guy and this guy. So we got to subtract the x's, negative 4 minus 0 squared. And then 6 minus 3 squared. So that's going to be negative 4 squared and 3 squared. So that's going to be 16 and 9. That's going to be 25, which is 5. So we do get 5. Therefore, yes, triangle ABC is isosceles. All right, it is isosceles. What is the here's another application of distance formula. What is the diameter of a circle C with radius CD? Okay, so I have a circle, and I have diameter CD. No, I have radius CD. My bad. I have radius CD. Well, that's okay. If I find the radius, I just double it for the diameter, right? So I'm going to find the radius. So, and that's the distance between C and D. See that? The distance between C and D is going to be my radius. I'm going to switch colors just so we don't get confused here. Blue. Blue, please. All right, so radius, R, that's going to be this right here, is going to be the distance between C and D. So that's going to be the square root of 8 minus 3 squared, and then subtract the y, 16 minus 4 squared. So that's going to be 5 squared plus 12 squared, which is radical 169, which is 13. So my radius is 13, and they want the diameter of the circle, so I just double that. So my diameter is going to be 13 times 2, which is 26. So the diameter of my circle would be 26. And again, I use the distance formula to find the radius, double that to get diameter. So just different examples of where you might use that distance formula. Midpoint of a line segment. Okay, the midpoint formula. The midpoint formula is very simple. You just take the average of the x's and the average of the y's. If you think about it, it should make sense. Think of a line segment. Okay, I have a line segment, boom, boom. Let's say this is A and this is B. I want to know where the middle is. I want to know where the middle is. Well, if I have an xy value here, and then I have an xy value here, I have a point here and a point here, I need the middle of the x's and I need the middle of the y's. So I need the average of the x's and the average of the y's. How do you take an average? You add two numbers and divide by 2. If you have an 80, if you got an 80 on a quiz and then you got a 90, who's got an 80 and a 90 on a quiz, right? If you got an 80 and a 90 and you want to know your average is 85, right? Because it's right in the middle of 80 and 90. So you can add 80 and 90 and divide by 2 and you'll get 85, all right? You guys should know that. So the same thing, that's what a midpoint is. It's an average. It's an average. Average of the x's and average of the y's. So if I want to find, this one here is giving us the midpoint. It does say you use the midpoint formula. I'm not even going to use that here though. I'm going to draw this one out. I'm going to do this. I'm going to say, all right, I'm going to draw this one out on a graph. A is negative 1, 2. That's going to be like, I don't know, like right there. So that's A. And then M is 3, 4. 3, 4 right there. So there's A, there's M. And then B, M is the midpoint. So here's AM, but M is the midpoint, so B must be like over here somewhere, see? You can estimate where B is, right? But this is what we're going to do. A is negative 1, 2. Just kind of use logic. A is negative 1, 2. M is at 3, 4. Okay? So how do you get from, and you got to take the x's, so x's and y's separately. Do the x's and y's separately. So x went from negative 1 to 3. It went from negative 1 to 3, so it went up 4. Negative 1 to 3 is going up 4. So I'm trying to find out what b is. So I go from 3 to here. I have to add 4. Again, I added 4 from negative 1 to 3. So I got to add 4 from 3, and I should be at 7. And then for the y's, it went from 2 to 4. So I added 2. So from 4 to here, I need to add 2 again. So 4 plus 2 is 6. So I know that my point B must be 7, 6, because I just did the same thing from A to M as I did from M to B. That makes it that makes M the midpoint. So I didn't even use the midpoint formula there. This one I am going to use the midpoint formula. This is supposed to say parallelogram. You can't just say quadrilateral. This is supposed to say parallelogram. By the way, this is midpoint formula, not midpoint formula. I noticed that. This is supposed to say parallelogram, A, B, C, D. That way, when we draw the diagonals, we know that they bisect each other. The diagonals do bisect each other. So we have A, B, C, D. And then E is in the middle. So E has got to be the midpoint. When you have a parallelogram and the diagonals cross, E is the midpoint. So determine E. They want you to determine E if they give you A and C. So here's A and here's C. So they give us A and they give us C. They want us to find the midpoint there. So the midpoint is going to be using the midpoint formula. So it's going to be x1, negative 3, plus x2, which is 5, and then divide by 2, comma, y1, 4, plus y2, 7, over 2. And it's a point. Remember, it's a midpoint. Your answer's got to be x comma y. All right, so this is 5 over, negative 3 plus 5 is 2. 2 over 2 is 1. So this is 2 over 2, comma, this is 11 over 2. So this is 1, and this is 5.5. So the point E is 1, comma, 5.5, and that's just using that midpoint formula. If you're not sure, ask in class. I will help you a little bit more. Other than that, I will see you tomorrow to practice this a little bit more.